Hi, in this video, we will continue to talk about R programming. Today, we will talk about loops, for loops, while loops, and repeat loops. The most commonly used loop in R is for loops. Let's see one example. So we first define a sequence of consecutive even numbers between 0 and 10, using SEQ 0, 10, 2. So X has 6 even numbers between 0 and 10. Suppose we want to calculate the square of each number in X. We can do the following. First, measure the length of X using the length function and save it in n. So n is equal to 6. Then write a for loop. For parentheses I in 1 colon n. 1 colon n is basically 1, 2, 3, 4, 5, 6. And then parentheses y is equal to xi squared. Xi is the ith element in X. Last time we talked about how to extract a particular value from a vector using a square bracket, right? So this is the ith element of X, and we square it and assign it to y, and after that we print y. So in the first iteration, I is equal to 1. So y is equal to x1 squared, which is 0 squared. And consequently, when we print y is equal to 0 squared, which is 0. And then go to the next iteration, I will be equal to 2. Then y will be equal to x2 squared, which is 2 squared, which is 4. So that's why the second number is 4. Until the last iteration, I is equal to n, which is 6. X6 is 10. 10 squared is 100. So the last number is 100. And then the loop will be ended. So this is a for loop. So it works. However, it's not ideal because you see only the last number is saved in y. In each iteration, y will be overwritten. So the last number is saved, but the first 5 numbers won't be saved. Alternatively, we can first define an empty vector y. Okay, so see, we can use this. Y equals numeric n. So this will be an empty numeric vector with n elements. And then we will use this for loop to gradually fill the elements in y. So yi is equal to xi squared. And then all of the numbers will be saved in y. So this is a better practice. So let's see the general format of a for loop. For, parentheses, index, in, nvec, parentheses, action. So this index is called the looping variable. You can use any letter I, J, K, A, B, C, M, N. Any character string will work. And then in is a keyword. And nvec is a set of values that your index variable will loop over, will run over. Usually we will use a sequence of consecutive integers like 1 to 10, but it's not necessary. You can specify any set of values, may not be consecutive at all. And then we need to use curly brackets to wrap the statements in the action. So action is a grouped expression or group statement. And oftentimes the looping variable will be involved in the action part. For example, in the previous example, you see in each iteration, yi is equal to xi squared. So the looping variable I is used in the action part. So this is a for loop. And in R, loops can be avoided in many situations using a feature called vectorization. So this will make loops implicit in expression. For example, let's see, we have 2 vectors, x is equal to 1 to 10, and y is equal to -1 to -10. And n is the length of x, which is also equal to the length of y, because x and y have the same length. And then we want to calculate the sum of x and y. We first create an empty numeric vector z, then use the for loop to define each element of z. So zi is equal to xi plus yi. And then we print z out, we get a vector of zeros because you see x and y are exactly opposites of each other. Alternatively, we can just add x and y together and assign it to z. We get exactly the same result. So this is called vectorization of the loop. So the loop is implicit. You see, still there will be 10 iterations, but we didn't use a for loop or any other loop. This vectorization of the loop is possible because in R, all calculations are done element-wise. We have seen many examples before. Okay. So because loops are slow in R, whenever it's possible, we try to use vectorization features of R to avoid explicit loops. But in practice, many times, the actions are quite complex, which involve very complicated calculations, so vectorization might not be feasible. Let's see the other two types of loops, while loops and repeat loops. So this is a standard syntax of a while loop: while, parenthesis, condition, action. A while loop will perform the action whenever the condition is true. The condition is a conditional expression which yields a true or false value. Whenever the condition is true, the action will be executed. Otherwise, the while loop will be ended. And repeat will repeat the action forever until it encounters a keyword break. So in general, repeat loops are more flexible than while loops, and while loops are more flexible than for loops. And it is a good practice to use the least flexible solution to a problem. So you should always use a for loop whenever it is possible. And notice that in order to use a for loop, you must know in advance the set of values you want to iterate over. However, in a while loop and a repeat loop, this is not required. You see, there is no index variable required in the condition part or in the action part of the repeat. Okay. Let's see some examples. First, a while loop. So this is a for loop we used before. Let's rewrite it using a while loop. So we first initialize a variable I, let it be 1, and then while I is less than or equal to n, we let yi be xi squared, and then we need to update the value of I. I is equal to I plus 1. We add 1 to I and then keep going. So at the end of the first iteration, I will become 1 plus 1, which is 2. And then go back and check. 2 is still less than or equal to 6. So the loop will continue. And then at the end of the sixth iteration, I will be equal to 6 plus 1, which is 7. And then go back and check the condition. 7 is greater than 6. So the loop will be ended. So if you want to use a while loop with an index variable, looping variable, you first need to initialize the value of the index variable. And within the while loop, you need to manually update the value of the index variable by adding 1 to it. Okay. So it's quite different from the for loop. In the for loop, because we have the preset value 1 to n, we know exactly the starting value of I and the end point of I. So we don't need to initialize I, and we don't need to manually update I. So if there is a looping variable that we can use, then a for loop will be a better choice than a while loop, apparently. Then I see a repeat loop. So let's rewrite the for loop using repeat. We first still need to initialize the looping variable I, let it be 1, and then repeat yi is equal to xi squared. Manually update the value of I. In the last iteration, I will be equal to 6 plus 1, which is equal to 7. Then we set an exit. If I is greater than 6, break. That means the repeat loop will encounter a break keyword and the loop will be ended. So when we use the repeat loop, we need to pay attention. We have to set an exit so that the loop will be ended sometime. Otherwise, it will become a dead cycle and we will have trouble. Alright, that's all for this video. In the next video, we will talk about how to define functions by ourselves. Thanks for watching. See you next time.